Thank you, Roger. I'm here to present our study of location privacy in crowdsourcing application. This is joint work with Spiros, Matthias, and Stefan, who at the time that we were doing this thing were at Swiss Data Science Center and the University of Darmstadt. Since then, they left those places. That's why you're stuck with me. So I hope to live to Spiros' expectations. Crowdsourcing applications are those in which service providers, instead of collecting data themselves, they try to get the crowd to give them data. And concretely, in this project, we studied mobile crowdsourcing applications in which service providers use the mobile clients for the users. They give them applications, so they give them specific mobile devices to collect geolocated measurements that allow them to see how the world is going on. And you are used to use these things, like for instance, Waze or OpenStreetMaps are such services. But the fact that people can use these mobile services to just collect humongous amount of data actually is very nice. It has democratized the capability to collect large data sets. And this has made, for instance, scientists ride on these technologies more and more. There's very much leverage for citizen science, where people just need to take measurements about sounds in cities, radiation about the world. We have even a new version of Google Street Maps, where people just ask citizens to take photos of places so that we can replicate in an open source the same type of services. And this is a growing ecosystem. Since we started this project, not only a lot of applications appears, but also platforms like Spotron here, in which you can just build your new mapped crowdsourcing project. They will help you to build the app. They will help you to map the results so that you can get new data. And because you're privacy people, otherwise you would not be here on a Friday afternoon after a week of talks, by now you're all in panic about this thing, right? We're collecting geolocated measurements. But also because you're privacy people, probably you're thinking, but come on, why is she talking about this thing? Didn't we solve the location privacy problem already? By now we have optimal, perfect, efficient privacy-preserving mechanisms. But while doing this project, what we discovered is that so far the literature has been focusing on these particular location-based services: find the nearest restaurant, find my friend, or let's check in Forest Square to become a mayor, which makes rich many companies. But it's a very particular service. But these others are very different. First of all, they don't focus on the location. They focus on the measurement. So they also collect measurement with the location. And the utility of these applications is on the measurement domain. These people care about what comes with the location, not the location itself. And as opposed to location-based service, where the utility is user-centric, so when I look for the nearest by gas station, the utility is for me, and it's only based on my location. In the case of mobile crowdsourcing services, this is a collective utility. So the service provider would take the measurements of several users on the same location and use that to get utility out of it. And we also observed that the collection pattern and the movement pattern of using in the systems is different. In location-based service, we have often a sporadic type of things, a step off on the mapping and routing. All of the rest are, we just check on the services from time to time. Many of the mobile crowd services actually have continuous locations where people keep measuring, because that's actually what's useful for the service. So we conjectured that this would have a very different privacy implications, and to make this study, we use publicly available data from two of these mobile crowdsourcing projects. One of them is Safecast. Safecast is a platform that, after the Fukushima big explosion, decided that it was important to know about the radiation in the world. And because no government actually kind of finds, let's map how much radiation are we living on, they decided to take advantage of people. They build an open hardware device that measures radiation. You can buy it, and then users, this device will collect the location, time, and radiation measurement, and will send this back to the Safecast server. And Safecast would use this information to map radiation levels across the world, such as the map that you see there. It will try to find hotspots and new variations and specific things that happen. And they also publish all of this data with an API, and their data policy is open data, use it for whatever you want. And this data comes identified. Many of the people just upload this data with their names or with a pseudonym. And this data set we used after some cleaning, 56.7 million data points for 540 users. And we also started another service called Radio Cells that aims at making a mapping of the telecom infrastructure, so different service providers, where do they have their antennas, what is the service they provide, to provide users some way of controlling actually the telco providers that rule our world. And here people provide the location, the timestamp, the cell information, and the strength of the signal, as well as the device properties, so that we know if this depends from whether I have a Samsung or an LG or all these things. And they don't publish the data set with names, as in the case of Safecast. They publish an anonymized data set, but because they publish all the device properties, we show in the paper that it's very, very easy to just link points from different people and just find their trajectories. And here we used, after some cleaning again, 4 million measurements from 568 users. And you may be wondering, well, I mean, you're going around doing privacy analysis on data that people put on the internet. If you were here before, Kurt already say, not because something is in the internet means that researchers can go and do whatever they want with it. So we went through our IRB, which in the case of EPFL is called Human Research Ethics Committee. And we had a couple of iterations with them to devise a good protocol in which we're doing this. The main concern was the legitimacy of the data use that we just found online and the lack of consent of these users for us to provide the data. We convinced them that privacy evaluation of public applications is very important. This is kind of privacy white hacking, right? If it's important for us to analyze the security of systems that are deployed and affect people, it is also important for the community to analyze the privacy implications of just putting data online in such high volumes. But we agreed that we would try to have a minimal impact on these users, so not do blanket attacks on everybody there, but just try to limit our inferences to a bit of data points to demonstrate that attacks are possible. And we also, they were very pressing on why do you not take consent from these users? And we were like, well, we don't have their emails. And actually, if you make us find their emails, we are collecting more data and misusing even more data. Or in the case of radio cells, we can de-anonymize them because we can trace them, so we can find their homes, we can find their works. We know we can do this thing, but now you're asking us to breach privacy to use consent. So in the end, they were kind of calmed down about that. We agreed to only publish aggregate or anonymize data of some particular cases, and we disclosed all of these to the applications before we came public, and this happened in August last year, which tells you how many times the paper got rejected before. So how did we need to check whether we could breach the privacy of the users? We have geolocated data. We know that this enables a lot of location-based inferences. And what we wanted to stress is that this inference can be automated. In particular, there is a lot of literature from the mobile community and the UbiComp and etc., where they just deploy more and more algorithms to just extract information from location. And to show how simple this is the only privacy attack in this conference that doesn't use machine learning. We just use a very simple clustering algorithm from the 90s called dbScan, which what it does is, given a point, it just tries to find a point that is close by. If it does find this point, then goes and tries to find another point that is close by until there are no more points close by. At that point, it considers all of those a cluster. And if this cluster has a minimal amount of points that we design, then it returns it to us. Otherwise, decides this is not important and goes and tries to find another cluster. And this is very nice because we don't need to define the number of clusters we want, the number of points, nor the shape of the cluster, which is very useful for our users that actually move in different shapes. And the clustering technique itself finds this without us defining it. So to validate it, we kind of attacked a bunch of users in Safecast, and we follow a two-step clustering. First, we just filter measurements in working hours so that we would not profile users in their recreational activities. We tried to find relevant clusters with DVScan, and we only took those that were longer than 30 minutes because we find out that there are many clusters that last for very little, which we conjecture works things like traffic lights or things like that where users were stopping for a while, and we didn't consider those relevant. And then we did a second step in which we broke these clusters because some of them were very big. Imagine actually one of us that was a university or at a company that has a big campus. That wouldn't allow us to really identify a point, so we could break down. And for the small clusters, we took the centroid and used online service to reverse geocoding and get the address. And many of these services already tell you what kind of building is this point on. And then, because these people had their names, we went on social media and validated whether the inferences we had done were correct. So we tried to infer the workplace of people for 34 Safecast users. As I said before, these are very few because we tried to limit very much the damage that we could make. Still, our reviewers, if you're here, one of them called us quite creepy, which I agree, but we needed to do it. We had 35% success, but we also have to say that for 9 of them, we couldn't validate our inference because we couldn't find their working place on the internet. The rest of them, either LinkedIn or Facebook, would reveal where they worked. We also found out 50 pairs of friends of people that were at the same time on the same place, so we could infer that they were friends or had some sort of relationship, which we could validate just by checking Facebook or Twitter. And during all of this, not because we actually wanted, just well debugging, we looked a lot about the point of interest, and we found many other things. We found Freemasons, we found Scientologists. We have a guy that has a Tesla because he stopped on every Tesla station between Arizona and Chicago. And we find many other things that actually, if you want to automate, probably they also can be done. We just didn't want to do it. And one surprising finding is that as opposed to location-based services or many other services, the amount of privacy seems not to be correlated with the amount of points these people release. And this is because people in these applications have different behaviors. Many of them, and in particular the one that give a lot of points, those are good contributors that just go around and take measurements in many places just to contribute more data to the platform, and therefore they take measurements in places that are not relevant to them, or they never stay at a particular place for a long time. And just to make sure that we were not lying here, we did a very small cross-validation on OpenStreetMaps. In the case of OpenStreetMaps, they do not allow you to automatically crawl their API to retrieve routes and GPS points from users, so we had to do this manually, and yeah, this was a very small set because there is so much time that one can spend clicking on a website. So does location privacy preserving mechanisms, do the ones that we have designed help these people? We studied the state of the art, so those mechanisms based on noise addition, and in this case we use geo-distinguishability, which gives location privacy, and very simple, you just add Laplacian noise in a 2-dimensional space to just obfuscate the noise. So from the yellow one here, you would appear in one of these red dots. And we also tried variations that are better both from a privacy budget. So the release strategy means that you would reuse the noise. If you don't are very far away from the previous point, you will reuse so that you don't lose epsilon budget. And we also checked optimal remapping, which is a technique for utility in which if GeoInt could give you all of these points there in red, you would choose the one that gives you the most utility. And for using that, okay, they have the ones that they would take the point that has the most utility. We have generalization, we just check the point on a grid. And we have hiding when we don't report all of the locations, right? We can check either report every that many meters or a random percentage. And the performance of these defenses, we measured them using the areas where the user moves and also the point of interest. So this would be the point of interest that we infer. And once we apply the defense, we would say we have a false negative if we miss the cluster of the point of interest, or we miss or we will have false positives if we infer wrong places. And we check precision and recall as the privacy metrics. And we would say we have a lot of privacy if recall is small or if precision is small. How do the defenses operate? So for geo indistinguishability, we see that the defense really does not depend on the parameter, depend on the users. It will have very different performance, and only when you really increase the noise, you would actually reduce the precision and the recall to 0. For rounding, we observed that only when you round to actually 2 decimals, so you have very, very big grids, you would get any privacy. And for hiding, hiding at random does not help because people generate points every day, right? You would still see a lot of patterns. And even release, we could have some kind of information again because people repeat many, many days the same location. It would still show up for many of the users. And again, users with more data surprisingly were protected better, but that is a question of the mobility patterns and not of the amount of data. But the problem here comes with the utility. We use the map, so we just compare the radiation map with and without privacy-preserving mechanisms, and we use the code from the providers because they are an open source project where you can just use it. And we find that effective defenses have significant utility loss. What this means is that if you would just take Fukushima and just make a grid over it, 53 of the points in the grid would move from normal radiation to dangerous, and 283 that would be normally extremely dangerous would appear as normal because of the noise that you would introduce. So the map could not be trusted anymore, and that is actually not useful, and Safecast people told us this is not something we can tolerate. Another very interesting finding is that optimal remapping does not work. Optimal remapping finds utility thinking about where people are the most time, but that does not mean that you want to remap all of the measurements to that particular point, because that is not the same utility as in location-based services. And we observe a similar utility degradation for radio cells. And while talking with Safecast, they told us that this is not the only thing they do. They also care a lot about this hotspot detection. So we compared what hotspot detection would be between the original and the other says. So we have the original on the top left, and we see that depending on the mechanism that we have, either a lot of hotspots would appear, and that's very problematic because false positives are expensive. Every time they have a hotspot, they send someone to look there. And false negatives are very dangerous because if they don't see a hotspot, they cannot analyze it. So none of the techniques actually help for this. So how can we help? Well, we can try crypto-based solutions. They're very expensive, but phones are powerful nowadays, so please try your best. And it's important to think about how to maintain dataset publication, because for them, being able to open science is something very important. They don't want to be completely closed. Learning from lousy data, it turns out that that's what machine learning do. I'm sure that somebody here can come up with a way of actually learn from this geodistinguishability noise, some of this hotspot, and work more in privacy evaluation techniques for them. We have our code online, but we would be happy to work with any usability researcher in how to turn this into something really useful for users. So takeaway, mobile crowdsourcing and crowdsourcing in general comes with new privacy challenges. And these are privacy communities that really, they're privacy conscious. When we contacted them, they said, we really want to do this thing, but we don't have good techniques, so we just go with whatever because we're altruistic and we believe in science. So engage with them. They will be happy of having solutions. And just look in your institution. Probably there is some social scientist or biologist that is already doing this and will be happy to get your superpowers. Thank you very much.
We've got time for a question while the next person comes up and sets up.
Okay, Carmela, thank you. Very interesting. A small question just to be sure. So the first database was to use pseudonyms, but if I understand correctly, in your research, you did not actually rely on or exploit the pseudonyms. Is it correct? So you only used the measurements themselves, right? So if the measurements did not have any identifier, that would not make any difference, correct?
So for Safecast, they were identified, and we didn't do, no, we linked all of the data points of one person.
Identifiers?
Sorry?
Including
we only analyze points per person to find their particular home location. In the other data set, they were anonymized, but we could link points together and we actually could find where they lived. We just didn't de-anonymize them because we didn't think it was ethical. But we used the information that we could link different data points to make our inferences.
So in the first database, you did use the
identifiers. But even if we didn't have identifiers, because they release the GPS per second, right? It's not true. It's not difficult to just find trajectories and link them on.
Yeah. Okay. Thank you.
Thank you again.